Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in this series Advanced Development in Grasshopper, where I would like to introduce you to a pet project of mine that many of my friends, colleagues, people from the community have helped me build together, which I hope will be extremely useful for you to learn more and dig deeper into how Grasshopper works and its relationship with Rhino Common. Because the problem is the following. You have seen me in previous videos build a lot of components that replicate functionality that is available in Grasshopper, like for example, how to take a curve and subdivide it in equal length segments, or how to take a surface and subdivide it in points in the UV direction. And it turns out that coincidentally, because Grasshopper tries to be very componentized, it's very atomic, it coincidentally happens that many of the components just happen to be straightforward implementations of functions that are available in the Rhino geometry namespace. So for simple things like creating points, creating vectors, etc., it's very simple to find in the documentation where those functions exist. But for more complex operations, sometimes it's actually not so straightforward to figure out what code is actually running inside of the component to perform operations and to yield results that are equal to what the vanilla component actually does. And it turns out that many of those are also not straightforward from the Rhino common. For example, if I want to subdivide a surface like this one, you have seen me in previous videos try to be divide surface and nothing really pops up. There's no method really. If I do divide curve, there is something, divide by count, divide by length, but it's a little tricky. And especially, for example, for a surface, there's just nothing right like that. So you saw me on the previous video, actually have to write quite some code already to figure out the a behavior that mirrors the native Grasshopper component. So what I have found across these years is that many of us who are very familiar with Grasshopper sort of have a difficulty transitioning to scripting and to building our own plugins, just because we know and we're very familiar with the functionality in Grasshopper, but we're not really familiar with how that functionality is actually developed using raw Rhino common, or just using C# scripting inside of Grasshopper. So what is the relation? How can we know in the first place, given a particular Grasshopper component, how can we know the code that is actually powering that component? And how can we learn to mimic that functionality using Rhino common? So what that is exactly what the project that I'm going to introduce you is trying to solve. And the project is called GH Sharp, or Grasshopper Sharp, a C# dictionary of Grasshopper 3D components. The idea is that this is an open source that I started now 2 years ago, and I'm still trying to wrap it up because, of course, I have like 17 other things to do always, and that has been built by, it was started as a project in my class in the design school at Harvard, and then it just got amplified by many more members by the community, and we have had contributions by a lot of people who have gently and very gratefully given their time to the project. And what the project is basically a way to give you an insight about how Grasshopper components may actually be developed internally. So what the component does is that it has what the project does is that it has a source folder where you can see all the categories that are available in Grasshopper. So for example, you can see we have math, we have sets, we have vectors, we have curves, you have each one of the categories. And inside of these categories, so for example, if I go to surface, you can see that for surface, I have analysis, I have freeform, I have primitive, and we don't have sub D because this was pre-Rhino 7. We have utils, etc. So we have a file, we have a Grasshopper file that mimics each one of the categories that we can unfold. So, and then inside of each one of those files, there are lists of C# script components that have code that is trying to mirror the functionality of the original component. So how can I actually read these files? Well, the way to access these files is you go to the GitHub repo, and I don't have a GitHub or Git playlist yet. I'm hopefully doing that very soon. But the way you do this is you go to the GitHub repo, you click on code, and if you're not in GitHub or you're not going to contribute, the easiest thing is just to download all the files in that date. No forking, no PR, unless you know what you're doing. So I'm going to download a zip. I'm just going to save it somewhere on my desktop, for example. And then the file just showed up here. I'm going to extract this to Grasshopper, sharp, master, something, something. And you can see that the structure of files shows up here. And as I was saying, in the source folder, you have folders for each one of the main tabs. And then inside of them, you have folders, you have files for each one of the categories. So for curves, we have analysis, division, primitive, etc. And what's interesting is that I can just now, for example, go open primitives. And what I can see is that I have a long list of components, just like these ones, also divided. So if you look at primitives, you can see that there's basically 4 sections, the first one, second one, third one, and the fourth one. So you can see that the components here are arrayed in the same order as in here. So if I zoom in, you can see that the whole project is pairs of vanilla component and C# implementation. And you can double click and you can zoom in and you can see the code that is running a version of that component. And you can see that the results are typically compared one after the other. So for example, let's fit a line through a bunch of points. Let's create a line between 2 planes, and then we can double click here and you can see that this actually needs a couple of intersections and finding points and particular elements. And for example, you can see a line from the starting point, the vector, and the angle. And you can see that there's actually a constructor that does that right away. And you can see that, for example, how can I do a circle? How can I do a circle from 3 points? Or if I were to go to surface, utilities, and I can go now to utilities and I can say, what is the code that is running behind, for example, surface frames? Well, it's the second component on top. So it's going to be this one here. So I have surface frames, the original component, and then I have surface frames. And you can see that there is quite some code here to create a data trees, to do some sanity checks, and then to create data, double for loop. This code is actually very, very similar to the example that you saw before in the previous video when we were doing nerves components. It's just that it has more safety checks, more data structure. It's a bit more complex because it's really trying to mimic the functionality of the original component as close as possible. Or for example, do I want to know how to create a loft between a bunch of curves? Well, that's going to be surface freeform. So let me open the surface freeform and let me look for in the file. Let me look for where is loft. Loft is here, so you can see that loft. It has a bunch of explanations here. There's something special about this, blah blah blah, and then it turns out that actually there's quite some code going on to do the loft thing. And this is just because doing a simple loft is actually quite straightforward, but mirroring all the options and all the different things that you have in Grasshopper available to you is not so straightforward. So, what this project basically is about is giving you C# script versions of as many components as possible. And you will notice that the project is not 100% complete. There are some components that are not, the output is not exactly as the original, or there are some other components where we really didn't know how to make this happen and we haven't figured it out yet. So we are open to contributions, or if you can dig in or contribute your own version of the component, we're more than welcome to accept those. But at the core, hopefully it's a very interesting project because it gives you an option to find any vanilla Grasshopper component. And like for example, for meshes, we have a lot of we have almost all the vector algebra and the planes, etc. It gives you an option to see for a component that you're already familiar with, to see what code is running inside, and therefore learn more about what is the relation between Grasshopper components and Rhino Common, or how to learn functionality from Rhino Common and apply it in your computational workflows. Okay? So I'm going to be posting a link to this project. Maybe it's a card. It's definitely going to be in the description. And again, I think that this is a great project if you want to learn more, or if you're writing a C# script and you know the functionality that you want from Grasshopper, but you don't really know what's the way of writing that in Rhino terms. Okay? So this could be a really good repository for you. Most of the components that we wanted to target are already done as of the recording of this video, but we haven't formally published it yet because I'm right now in the middle of writing a paper that I want to publish to document this work more formally, but also I want to do a launch party with everyone, all the grateful people, all the wonderful people that helped me build this together. I would like to make a launch party and officially throw this out in the world, and maybe have a virtual drink and all those things. So if that has happened, there will be also some card popping up somewhere, or there might be a link in the description to a video where that launch party is happening. Okay? But in the meantime, I hope this is going to be useful for you to learn more, and definitely use this as a way of improving your Grasshopper to C# skills. Okay? Thank you very much, and see you on the next video on this series. Oh, and if you like this video, maybe like it on the button, maybe subscribe to the channel, etc., etc. Thank you very much, and see you on the next video.